Welcome again. We're working on linear systems and two variables. We're working by the method of substitution, and this is the second example we're working with here with Professor C. So our second example is nice and simple. We have equation number 1, which is minus x plus 2y equals 9, and a second equation in green here, 4x plus 3y minus 14. So we look at these two equations, we're looking at what we're going to do. With substitution, recall, we're trying to make our lives very easy by isolating the simplest variable. 4x, maybe not, 3y, not so much, but we see that minus x up here. This is going to be a great candidate for isolation because we can just move it to the other side and we're pretty well done. So let's look at that. We're going to take equation number 1 and rewrite it. And we're going to rewrite it here, minus x plus 2y equals to 9. So we can start on it here. And we'll actually add x to both sides. That avoids the fuss of actually dealing with multiplying by a negative. We're just going to move it to the right side where it's going to be positive. So on the left side, minus x plus x is 0. I'm just left with 2y, and on the right-hand side, I'll have 9 plus x, which is relatively straightforward. I want x alone, so I'll do that by moving the 9 over by subtracting 9 from both sides. So I'll have 2y minus 9 on the left, and then I'll just have the x on the right. And now I've isolated the x part of this equation, and I can move on. Now I had the two equations, so with these two equations I'm going to want to look at equation number 2, which I'll rewrite here. Equation number 2 was 4x plus 3y equals minus 14, and I did find 2y minus 9 equals x, so I'm going to take that value and actually simply place it right here in the equation. So I'm going to rewrite that 4, and where I see x, I will write 2y minus 9 because that's what it is right here. So I just take this and put it right in there, and I still have equals 2 minus 14, plus 3y equals the minus 14 on the right, so that's got to keep that going. And now I just simply work that out. The 4 times 2y, that is going to be 8y. Don't forget we have to distribute the 4 to the minus 9 as well. That's going to be negative 36. I'll still have the plus 3y equals to negative 14 on the right side, so that's still going. Now I'll try to simplify what I've got. I've got the 8y and the 3y. Well, I can put those together and that gives me 11y minus 36 equals negative 14. Now I can simplify that even more by bringing the 36 over, so I'll add 36 to both sides. I'll have 11y equals to negative 14 plus 36, that's 22. I could complete my isolation of y by dividing both sides by 11. 11 by 11, this is the same as 1. So I just have 1y, I'll just write y here for that, and 22 divided by 11 will give me 2. So all of that work, and now I've got y equals to 2, but I still have my two original equations. So what am I going to do with that? Well, I'm going to take that y value and I'm going to put it into either of my equations to find the x value that corresponds to it. So I'll work with equation number 1, which is minus x plus 2y equals 9. And in that equation, I said that y was 2. So that's going to be minus x plus 2 times 2 equals 9. Minus x plus 4 equals to 9. And that means that I'll have minus x is equal to 9 minus 4. Subtract 4 from both sides. Minus x equals to plus 5. And just a little bit more work. If I multiply both sides by the negative 1, I will have x is equal to negative 5. So that's great. Now I've got two solutions, or two values, really. I've got the y equals 2 and the x equals minus 5. So I'll carefully write that out as a solution. That means that I've got x comma y minus 5 for x, y is 2. So that's an appropriate way to represent the solution. This is a value or set of values x and y that satisfy both equation 1 and 2. So to make sure, I'm going to go back to my equation 1 and 2 right here. And I'm going to go ahead and plug that value into equation 2 just to make sure it works. So if I do that, my equation 2 is 4x plus 3y equals minus 14 here. And if I put negative 5 for x, 2 for y, multiply it by 3, as my equation says. So I'll get negative 20 plus 6, and that is indeed equal to 14. So I've shown in equation 2 that the point negative 5 comma 2 works, satisfies the equation. And by the way, when we were solving here back in equation number 1, we actually showed that it works also in equation 1, because that's what we used to find it in the first place. So that's going to be a solution to our minus x plus 2y equals 9 and 4x plus 3y equals negative 14. Since I've checked it, I will put it in a nice square box because I'm really confident with it. And if I'm really happy, maybe even put a flag over here to show that we're really happy with that.